Hi guys. Today we are going to learn how to factor quadratics. So before we get into looking at quadratics, let's just talk for a minute about what it means to factor something. So factors are numbers that go evenly into another number. So if I have the number 10, the factors of 10 are 1, and 10, and 2, and 5. So I could write 10 in factored form by either writing it as 1 times 10 or 2 times 5. Both of these still equal 10, but this is a different form of writing it, and it's written in what we call factored form. So 2 is a factor of 10, and 5 is a factor of 10. If I multiply them together, it equals the same as 10. So that's kind of the idea of what we're doing, but we're just doing it with quadratic equations. So before we start, I just kind of want to show what we're doing here. So if I have x minus 4 times x plus 5, x minus 4, we can think of that as one of our factors, and x plus 5 is another one of our factors. If I multiply these together, it's just like the same as on the previous slide. If I have 2 times 5, I can multiply them together to get 10. If I multiply these two factors together, I'm going to get a quadratic equation, because x times x is x squared, and x times 5 is 5x, negative 4 times x, and negative 4 times 5 is negative 20. These two in the middle are like terms, so I could add them together. So this would equal x squared plus x minus 20. So this quadratic right here is said to be in standard form because we have the highest exponent first, and the next highest, and the one without an exponent. So x squared plus x minus 20 and x minus 4 times x plus 5, they are the same. Well, what factoring is it's actually starting in this form. We're going to start in standard form, and we want to get it back to this form. We're going to factor it to get it to look like that. So a couple of things to notice here are that this middle term right here, 1x, that was made by adding together 5x minus 4x, right? And then this last term, negative 20, that's made by multiplying these two together, negative 4 and 5. So we multiplied to get this last term. We added 5 and negative 4, which was two terms here, to get 1x. So let's look at an example. So the method that we're going to be using is called x factoring. So remember that a quadratic in standard form is a trinomial. Sometimes it can be a binomial. But this is the form ax squared plus bx plus c. So when we are looking at this, we're going to be looking for our coefficients, or the numbers in front of the variables. A will be the one in front of x squared, b is in front of x, and c is our constant. So when we're factoring, we want to look for two numbers that multiply to make a times c, and a number that adds, the same number should add to b. So when we say A, B, and C, we're talking about these numbers in front of the variables. They are in a specific order. A is with x squared, B is with x, and C is the constant. So let's take a look at an example. So we have 2x squared plus 19x plus 24. We want to get this in factored form, which means we're going to have two sets of parentheses. We're going to have one binomial here and one binomial here. Just kind of the opposite of the first problem that we did. We're going to use a method called x factoring. So I'm going to write a great big X over here. And in this X, I'm going to place A times C in the top. And I'm going to place B at the bottom. Now, we want whatever result we get for A times C, we wanted to find two numbers that will multiply to A times C, but at the same time, they should sum or add up to B. So that's why we did that little exercise at the end of the last assignment, of multiplying to this number and summing to this number. So A in our case is equal to 2. It's just the number in front of the variable. B is equal to 19, and C is equal to 24. So in this top part of my X here, I'm putting A times C, so that would be 2 times 24, which is 48. In the bottom of my little x here, I'm going to put b, and b is just that middle term again, remember 19, so that goes here. So now I'm looking for two numbers that multiply to 48, and at the same time, they will sum to 19. So we can just kind of start making a list. 1 times 48 is one option because 1 times 48 does multiply to 48. There's no way I could add that or subtract it to get 19. If I do 2 times 24, same thing, it will multiply to 48, but it won't add to 19. 3 times 16 is 48, and oh, yep, that one will work. 3 times 16 is 48, but 3 plus 16 is 19. So those two numbers that I found, I'm going to put them on the sides of the x here. Those are the two numbers that multiply to a times c and sum to b. So now I'm going to go over here and I'm going to write those. I'm going to put an x out front on both of my little polynomials or my little binomials, and I'm going to put my two numbers that I just found here. Since they're both positive, I'll put a plus. If one of them were negative, or if they were both negative, I put minuses right here. But if you notice, if I were to start to multiply that back together, I would get x times x, which is just x squared, and it's not 2x squared. So I still need to account for that 2 out front. And remember, when I started here, I multiplied that 2 times the 24 here to get the 48. We need to kind of undo that now, so we're going to divide both of our numbers that we found by a. Okay, so this step right here, we are dividing by a. That's where the 2 came from. It's the a term. Okay, now if a goes evenly into the number above it, we're just going to go ahead and divide it. So on this second one here, we can just go ahead and divide 16 by 2. That equals 8. On this other side, 2 will not go evenly into 3, so instead of dividing or leaving it like that, we're going to take the 2 and we're going to move it out in front of our x. So here's our factored form of 2x squared plus 19x plus 24. So if you're asked to factor a quadratic, this is the form your answer should have, and this is the result. That's what we were looking for. That's the answer to our problem of factoring this. I do want to quickly just multiply this back together just to show that it does indeed equal 2x squared plus 19x plus 24. So this is not part of the problem. You wouldn't have to do this. This is just for us to make sure that it is right and it is actually equal to the same thing. So 2x plus 8 would be 16x. 3 times x is 3x, and then 3 times 8 is 24, which gives us the 2x squared plus 19x plus 24. Okay, so that's just to double check, but the answer is the 2x plus 3 times x plus 8. Awesome, so let's try another one. Just practice that. Here we have x squared minus 16x plus 15. We know we want to get it in factor form, so I'm going to put my parentheses here. We're going to use our x factor method. Remember, up here we want a times c, and down here we want b. So our a in this case, if I don't see a number in front of x squared, would be 1, right? So 1 times 15 goes here. And our b term is negative 16, so that's going to go here. I'm looking for two things that multiply to 15 and add to negative 16. So for 15, I really only have two options, 1 times 15 or 3 times 5. That one is not going to add to 16, but this one will. But I need a negative 16, not a positive 16. So if I made these both negative, negative 1 plus negative 15, that does equal negative 16. So I will make them both negative, which, by the way, negative 1 times negative 15 also does equal positive 15. So these two numbers will work for me. So here I'm going to put x minus 1 and x minus 15. So I'm just taking the numbers I just found. I'm putting them after x here. So this is factored form. A in this case is 1. So when I divide by a, nothing is going to change, right? If a is 1, it's not going to change anything. So here is factored form of x squared minus 16x plus 15. And again, you could multiply it back and make sure it actually equals, but we're not going to take the time to do it on that one. All right, another example, x squared minus 8x minus 20. So our x factor here, we're going to do 1 times negative 20. Okay. We're going to do b down here, so negative 8. So what are two numbers that multiply to negative 20 and add to negative 8? So because this number here, the one that got multiplied to, is negative, I know only one of my values can be negative because a negative times a positive is what gives me a negative. I could try 1 and 20. I'm kind of ignoring the signs for a minute just to see if I can get something that either adds or subtracts to negative 8. 2 and 10, those ones looks like they could work. 2 and 10 does, if I subtract 2 from 10, I do get 8. And now I need to think about the signs because I know one of these is going to have to be negative and one is going to have to be positive. If I want my result to be negative 8, okay, if I made the 2 negative, wow, that's a big negative. So negative 2 and 10, that would give me a positive 8. So I don't want 2 to be negative. I want 10 to be negative because 2 minus 10 is negative 8. So 2 and negative 10 are those two numbers that will both multiply to negative 20 and sum to negative 8. And then I just write them out as in my factored form here, x plus 2 and x minus 10. Okay, so again, my a in this case was 1. So if I divide these each by 1, it's not changing anything. So this would just be the result of that. Okay. All right, we'll just do a couple more examples. So 2x squared minus 7x minus 15. The first step is to multiply a times c together, put it in the top of our x. So 2 is a and c is negative 15, so that would be negative 30. Okay. Then b, remember, is in front of x. That would be negative 7. So I'm looking for two numbers that multiply to negative 30 and add to negative 7. So 1 times 30, 2 times 15, 3 times 10. Okay, which one of these groups would give me either add or subtract to 7? So 1 plus 30 is 31, and 30 minus 1 is 29, so that one won't work. 2 plus 15 is 17, 15 minus 2 is 13, so that one won't work. 3 plus 10 is 13, but 10 minus 3 is 7, so these are the two that we're going to want. So now we got to think about our signs. I know that one of them has to be negative because our a times c is a negative. When I add them together, I want to get negative 7. So again, if I did negative 3, that would give me 10 minus 3, which is positive 7. So instead, I'm going to make 10 negative because negative 10 plus 3 equals negative 7. So 3 and negative 10 are those two numbers that multiply to a times c. This is a, b, and c, and add to b. So now I'm going to write this in factored form. X plus 3, choosing these two numbers I just found, right? And x minus 10. And I got to remember to divide each of these numbers by a. If it goes in evenly, go ahead and divide it in. So 10 divided by 2 is 5. If it won't go in evenly, I need to move that number in front of x. So this would be 2x plus 3. So there's our factored form. All right, one last example really quickly. Maybe if we can get this to advance. X squared minus 4. So here we have a is 1, that's in front of x squared. Our x term is missing. So that means our b has got to be 0. And then our c is negative 4. So here I have up here a times c would be 1 times negative 4. B is 0. So I'm looking for two numbers that multiply to negative 4 and sum to 0. So for 4, I've either got 1 and 4 or 2 times 2. So again, I just ignore the sign for a minute and then I figure it out later. So 1 plus 4 is 5 and 4 minus 1 is 3. So either way, I'm not getting 0. But for 2 and 2, if I do subtract one of them from the other, I will get 0. So the two numbers that multiply to 4 and add to 0 are 2 and negative 2. So this would just be x minus 2 times x plus 2. Again, I would divide by a, but here it's not changing anything. So that's our factored form. Good luck, guys. Have fun.